Lesson 8.5.11, Cylinders, the volume of a cylinder. In this lesson, we'll explain the parts of the formula for the volume of a cylinder and calculate the volume of a cylinder. We're on page 40 in your workbooks, and I'm hoping that you've worked through the activity for lesson 11 to get some reminders about just volume in general and what volume means. Our goals are to explain the parts of the formula for the volume of a cylinder, explain the parts of the formula, for the volume of a cylinder, and also to calculate the volume of a cylinder with that formula. All right. So let's start with explaining the parts of the formula for the volume of a cylinder. And here's the formula for the volume of a prism that maybe you've looked at before. The volume of a prism, and let me clarify what a prism is. A prism is really two things. It has two congruent bases. I'll show you what I mean by a base. So these two parallel sides that are the same shape would be the bases. I'm going to hold off on this last one because technically it's not a prism because it has curved sides. But two congruent bases that are parallel to each other. And the things connecting those bases are these rectangular shapes. They're called faces. That's what makes it a prism. So you can see there's 1, 2, 3, 4 rectangles on the left, right, front, and back of this prism. The base here is a pentagon, so there's really 5 rectangles going from one base to the other. 1 on the left, 1 on the right, kind of 2 in the back and 1 in the front. Maybe it's hard to see. And we'll get to the cylinder in just a moment. But if we have two congruent bases, then this is our formula for the volume of that kind of figure. Let's explain what each of these variables mean. When I say the volume is equal to capital B times H, well, let's start with the V. V stands for volume. And that's just the space enclosed by the sides of a three-dimensional figure. So imagine filling this up with water, okay, like a big, tall aquarium. The other two parts of this we're really going to zero in on. Big B really represents the area of that base, that figure that has a congruent top and bottom. And finally, we have the height. And the height is this distance between the two bases. So this length right here is the height. So we can use the same information. Volume is equal to the area of the base times the height of the figure, even if our figure doesn't have rectangular sides. I can still apply that same notion. So I've got these two circular bases. I just need to be able to figure out the area of a circle, and then I'll multiply it by the height. So this is the figure we're really focusing on today. The volume of a cylinder. But to find the volume of a cylinder, we have to first recognize that we'll need the area of this circle. So let's quickly recap how to find the area of this pink piece right here, this circle. The formula for that is pi times the radius squared. We'll talk more about what squared means in just a moment. But I'm going to take a quick side note here. I made this very primitive looking reminder of a few things. So the area is the space enclosed by a shape. And we're going to see an awful lot of information about circles. Sometimes we'll be told the radius, which is really what we want in all of our formulas. And sometimes we'll be told the diameter. That's the distance all the way across the circle through the center. And I want to clue you in, if you're given information about the diameter, cut it in half. What you really want is the radius if you want to use it in a formula. So if you're told that the radius is 4, great. Go ahead and substitute 4 in for the radius in our formula. But if you're told that the diameter is 8, don't substitute that in for the radius. You'll just need to remember, anytime you're given the diameter, you're going to want to cut it in half to find the radius. So I just wanted to remind you of those two vocabulary words from the past. Okay. So with that in mind, the volume of this cylinder is the area of the base times the height. Let's scooch up and actually calculate the volume of a cylinder. And I'm going to take the formula one step further. I think you'll see what happens here. So the volume is equal to the area of the base times the height. Well, if we're talking about cylinders, the base is always going to be the same shape. Now, you'll notice that this is tipped on its side. I know when you think base, you think bottom, but what I'm really looking for are those two congruent parallel sides. The circle is the base. And again, since in a cylinder, the base is always going to be a circle, and I know that the area of a circle is equal to pi times the radius squared, this is what's going to become part of our formula. The area of the base in a circle is pi times the radius squared. And I'm still going to have to multiply by the height, so I'll throw that on at the end. But this part is the base. So that's our volume formula for a cylinder. This will work for any figure that has a top and a bottom. It doesn't matter if it's a rectangular prism or a pentagonal prism or a cylinder. But since we're going to be focusing on cylinders, this is the formula we want. Okay, so let's go ahead and find the volume of the cylinder, exactly or rounded. We'll talk about those two words in a moment. Rounded to the nearest tenth. So if we have a formula and we're trying to find the volume, then we need to know these other dimensions. Now, pi isn't really a variable. Pi is a value. It's always the same value. It's 3.14159, goes on and on and on and on. We'd have to round it if we were going to plug a number in there, but it's always the same number. It's a constant. What we need to substitute in is a number for the radius. So let's come over here to our circle and look at the dimensions we're given. We're given this dimension, and we're given this dimension. Now, remember, the height is the distance between the bases. So even though this looks like it's on the bottom, this is the distance between these two pink circles. That's the height. So I'll be substituting that in for h. Let's look at the radius of the circle. Well, here's our pink circle. And I know that from this side of the circle to this side of the circle is 6 centimeters. Let me remind you, though, that's the distance all the way across the circle. The diameter is 6 centimeters, which means the radius is 3 centimeters. And the radius is what we want for our little formula. All right, so let's go ahead and start substituting in numbers. So the volume is equal to, well, there's pi. There's the radius, which we decided was 3 centimeters. Don't forget to square that. And then the number we found for the height was 5. That's the distance from the two bases, or between the two bases. Okay. So all these things are multiplied together. Let me remind you quickly what 3 squared means. When we square a number, we multiply it by itself. So this is pi, and this is really 3 times 3. 3 squared is 3 times 3. And then I still have this times 5. When we multiply a bunch of stuff together, it doesn't matter what order we multiply it in. But this might be a good time to talk about the difference between finding the volume of a cylinder exactly and finding the volume of a cylinder rounded. Let's start by finding it exactly. And this is how most mathematicians will leave their work, and you'll see it all through this part of the unit. They don't write 3.14 for pi. In fact, they just multiply the numbers that they can. 3 times 3 is 9, and 9 times 5 is 45. And most mathematicians will say that the volume of this cylinder is 45 pi. I didn't round anything anywhere. I just left pi the way it was. And volume is measured in units cubed because it's a 3-dimensional figure. So this is the volume exactly. I haven't rounded that pi and lost accuracy. Mathematicians don't like to round and lose accuracy. But it's also acceptable in most cases, if you want to round things, to go ahead and multiply 45 times this approximation of pi. Pi is not really 3.14. That's a rounded approximation. But if you wanted to use it, you might see it happen. If I round that to the nearest tenth, actually, let me do this. 3.14 times 45. Oh, it's already at the nearest tenth, 141.3 centimeters cubed. But that's an approximation. That's rounded. Most mathematicians are happy when information is precise, and they're sad when information is rounded, but sometimes it has to happen. So don't be surprised if through the unit you see things left as 45 pi instead of rounded to 141.3. All right, well, this is a good start. How is finding the volume of a cylinder like finding the volume of a prism? Well, for both kinds of figures, you multiply the area of the big base by the height. In our case, in a cylinder, the base is just going to be a circle. So that's our first formula for the unit, one of many that involves the radius of a circle and pi, which we'll get real comfortable managing. Go ahead and get started on the practice assignment, and good luck.